Hello everybody, let's solve this geometry problem. What we're given is angle OPQ. Angle POQ is of 90 degrees. The side OA is equal to A, and the side AP is equal to C, the side AQ is equal to B, and the sides OP and OQ, they are each of length X. Okay, and on top of that we're also given twice a square plus b square is equal to c square. Okay, we're given this. And what we are supposed to show is that x square plus a square, x square is equal to a square plus square root of 2 times ab plus b square. Okay, now to do this we're going to use two things. First, we're going to use the SAS axiom of congruence. And second, we're going to use the cosine law. Okay, the cosine law. Now, first of all, let's try to use SAS axiom of congruence. Now let me call this angle as alpha. Then since the entire angle QOP is equal to 90 degrees, it follows that this angle is 90 degrees minus alpha. Okay. Now to use SAS axiom, let's see. We're going to construct a triangle congruent to angle OAQ, congruent to this triangle. Okay. Now to do that, we need an angle alpha, a side of length A, and a side of length X. Okay. Now for the side of length X, we have the line segment OP. Now let me construct an angle alpha. Since alpha is less than 90 degrees, we can construct it like this. Okay, this angle to be alpha. Now along this dotted line, we can also take a length OA dash such that OA dash is equal to A. Okay, it's always possible. Now since alpha is fixed, A dash is fixed, we can join the point A dash to the point P like this. Then let's see. Let's focus on this triangle. Okay, let's focus on this triangle. If we focus on this triangle, what can we say is that the triangles AOQ and triangle OA-P, they are congruent because between the sides of length X and side of length A, we have an angle of alpha. So by SAS axiom of congruence, these two triangles are congruent. And so since corresponding sides of congruent triangles are equal, the side opposite to angle alpha should also be equal. Since the side opposite to alpha is B, the side PA dash is also B. Okay, this is what we get. This is the first step. Now, next what we are going to do is that we're going to join the points. We're going to join the points A and A dash. A and A dash. Then we're going to have this triangle. OA. Okay, OA. This side is A, and we have a brown line. This is also of side A. This is A dash, and a red line joining A and A dash something like this. Okay, now this side and this side, they are equal. And also this angle, angle AOA dash, AOA dash, this angle is equal to 90 degrees, because this angle is 90 degrees minus alpha and this is alpha. So 90 degrees minus alpha plus alpha is equal to 90 degrees. Okay, so we're going to get a right angled isosceles triangle, and as a result of which this angle will be 45 degrees, this will be of 45 degrees. We're going to use it later on. All right, and using Pythagoras theorem, or you can use the trigonometry over here, we're going to get side AA dash as square root of a squared plus a squared, which is equal to square root of 2 times a, or you can write a square root of 2. Okay, and this is it. So this side is a square root of 2. Now let's focus on triangle uh, AA dash P now. Okay, let's focus on triangle AA dash P. To do that, let's see, here's A, here's C, here's B, and here we have A dash B. So we have a brown dotted line, looking something like this, which is equal to B, and a red line connecting A and A dash. All right. Okay, this is A root 2, this is B, and let me call this angle phi. Then using cosine law, we can say that cosine of phi is equal to this squared plus this squared minus this squared. So square root of 2a squared plus b squared minus c squared over 2 times the adjacent sides ab square root of 2. This will be equal to twice a squared plus b squared minus c squared over twice ab square root of 2. Now let's see. Twice a squared plus b squared is equal to c squared. Okay, now we're going to use this condition, and we're going to get this as c squared, which cancels the other c square out, and as a result we get cos phi is equal to 0. Now since phi is an angle of a triangle, this should be strictly between 0 and pi, that is 0 degrees, phi, and 180 degrees. So this trigonometric equation has a unique solution, which is phi equals 90 degrees. Okay, so what we have is this angle as 90 degrees. Okay, this angle as 90 degrees, and this angle was 45 degrees. 45 degrees. Now we're almost done. Finally, let's switch our focus to triangle OA-B. Okay, OA-B. Here's O, here's P, and here's X. And A dash was something like this, I guess. Yeah. O A dash, this was A, and this was B, and let's look at angle OA-B. OA-B. Okay, OA-B, this angle 45 degrees plus 90 degrees, 135 degrees. Okay, 135 degrees. So this angle is of 135 degrees, which means using cosine law, cosine of 135 degrees will be equal to a squared plus b squared minus x squared over twice ab. Cos uh, cos 135 is equal to 1 by square root of 2. This is equal to a squared plus b squared minus x squared over twice ab. This will give us square root of twice ab, which will give us square root of 2. ab is equal to a squared plus b squared minus x squared. So changing the positions of these two expressions, we get x squared is equal to a squared plus square root of 2ab plus b squared. Alright, now this was what we were supposed to show, and we did it. So the solution is complete. Okay, alright, thank you everyone.